Here we're going to talk about graphing functions with the number e. So we've got y equals a times e to the r times x. And this is a natural-based exponential function. The a right here is just like we see in any other exponential growth or decay function. It just stretches or shrinks the graph. And so here if we got a is greater than 0 and r is greater than 0, then it's exponential growth. Here if a is greater than 0 but r is less than 0, it's exponential decay. So these are the basic functions of e. I forgot to write that here, but I'm going to say y is equal to e to the x. And so our two main points right here, we've got 0. If we put in 0 to this function, we've got e to the 0, which is going to be 1. And that's where it crosses the y-axis. If we put in 1, it's just going to be y equals e. So it's the coordinate here is going to be 1e, and e is about 2.718. And over here, let me write that y equals e to the negative x. So here's just this graph basically flipped around. So this is a decay function here. It's where we've got negative 1e right here and 0, 1. And here's a real quick example, just to show how the e function can be graphed. We've got y equals 3 times e to the 0.25 times x over here. We can also call that 1/4, whichever way you want to write it. We've got here our r is greater than 0. We've got 0.25, which is still greater than 0, a small value, but still positive. So it's going to be exponential growth. So the easiest way to, well, if we had more numbers, you could make a chart to make it a little easier, but I just wanted to show you the ordered pairs here. So we've got 0, if we put that in up here, we're just going to end up with 3, because e to the 0 is 1. So at 0, it's going to be 3. And if we put in 1, it's going to be 3 times e to the 0.25, which if you put in a calculator, you're going to get about 3.85. So you can plot that point right here. So notice that this graph has been stretched out by the scalar number 3 that we put in. So 3 is our a value. Let's stretch this graph out.